I'm gonna wait. Right. Okay. So the key thing about this, I'll do the software one. I won't overload you. We'll just do the hardware one to start with. The key thing about this is that you're not just describing these things. You've got to try and always think in your mind. If you need to put a context down, the context is gaming, because that's what this unit's all about. Okay. So, unfortunately, to get a pass, you've got to cover all these items, and I do apologise for that. I'm not asking for breathtaking detail, but I need to know what each of the items are. Now, some of these things you're actually going to know anyway. Some of these things you may find that last year when you did Unit 2 or the 2 technician units that you did with John, you might have actually written descriptions of these, so you've probably got stuff that you've actually written already that you can probably just... You must have talked about CPUs and things, and graphics cards and stuff like that. So you've probably got some stuff. So let's just run through. They're under various categories. Okay, so the first category, Human-Computer Interface, HCI. You're actually doing a unit on that with Gavin, aren't you? Because that's to do with your multimedia product. So he's actually doing that. So we've got to talk about these aspects. Now you might have, on your first assignment, talked about some of this stuff when you were doing your merit and distinction stuff. If you talked about like ergonomics of a controller layout, then you've already got some stuff there. You don't need to repeat yourself. If you've done that, you can make a signpost. So you can say, oh, discussed controller layouts in merit for assignment 1. Only if you've done that though, don't just say that. Alright, but if you have actually covered, I don't want you to repeat stuff, there's no point. It's all in the same folder, so that's okay. So you just need to talk about ergonomics of the controllers, really, because it's the controllers, keyboards maybe, okay? But I mean, that's up to you, but you just need to say what that means, ergonomic design. You did a little bit about it when you do like health and safety and stuff. Interfaces. Okay, so the interfaces are the sockets. We all know how much a pain in the neck USB sockets are, because you have to get them the right way around. USB-C is a million times better. Why they didn't do that, well, we know why they didn't do it. They didn't want to put extra cables in there or extra little connectors. Okay, what a shame they didn't. So could have done that at the start. So make sure you talk about that. User-centered design, anyone know what that might mean?
User interface.
Yeah, user interface, but aimed at the user. So it's like making decisions that maybe not are easy things to implement, but they're best for the users. Okay, but you need to do some research on this. And portability, what do we mean by portability? I do not mean carrying something around, because we're talking about interfaces. What do I mean by portability of interface?
Is it like changing devices?
Yeah, switching between devices and having consistency as best you can. You can't obviously, if you're using a desktop machine, you've got massive screens. You may have multiple monitors. You can't replicate the same interface exactly on a mobile screen, but you can get the same emphasis. All right. So that's actually quite a wordy bit. That's quite a tricky one. You're going to have to make sure you look at a variety of sources to get some sort of sense out of that. Ergonomics is pretty easy. It's about comfort. That's not hard. But the other ones, things like this, user-centered design and portability, you're really going to have to make sure you don't just rely on one set of sources for that. Okay, the next one a little bit more solid, CPUs. The different types of CPU. Okay, so we don't just mean manufacturers. So I don't think like AMD, Intel, they're manufacturers. They make the same types of CPU, desktop CPUs. But the other types of CPU, we've got mobile CPUs. So it's important, and you're relating this to games, remember, what are the differences between a desktop one and a mobile one, that sort of thing. Speed. How do we often quote the speed of CPUs? Gigahertz, not gigabyte, yeah, gigahertz. The actual clock speed. Okay, so how fast the compute unit works on the CPU. It's not actually a very good indicator these days. It used to be, if you had an 8 megahertz CPU and a 12 megahertz CPU, I did say megahertz there, megahertz, that would be probably 1.5 times faster, or 150%. Okay, but today it's not, because of the architecture. It's really strange, and it depends how efficient that architecture is used, and it depends what jobs you're doing as well. Okay. Anyone know what that is, RAM cache? Or anyone know what the word cache means?
Yes, it's saved data. Just logged into the computer.
Well, yeah,
When your computer's running tasks, it will save a bit of the.
yeah. So RAM.
Is it good enough?
Yeah, one of the problems we've got with normal RAM, it's a hell of a lot slower than the CPU. A hell of a lot slower. So every time we're fetching data to process, that is slow. Now, if you're into PCs and graphics cards and things like that, you'll know that the more graphics memory that the graphics card's got directly shared with it, the faster it's going to be able to operate. As soon as it has to dip out of that and go back to RAM, it murders performance. And that's when you get loads of chugging and stuff like that. So the CPU's got the same problem. It's processing data from RAM, and it has to like sort of twiddle its thumbs while that data comes along. This is why the clock speed isn't a good indicator, because unless the CPU is doing something else, it's not going to be using all that speed. So what we try and do is we have, you may have heard of these terms. You have something called level 1, level 2, level 3. There is actually level 4, but level 1, level 2, level 3 cache. Okay, and what this is a smaller amount of memory, but it operates very fast. In fact, level 1 cache is often sat on the CPU, with the CPU, so it can access it at roughly the same speed. That's tricky, because obviously if I update something in cache, I've got to update it in RAM, so it all gets horribly complicated, but it can help throughput. And as a programmer, if you know that everyone's got, say, 1 megabyte of cache, you can write code in a certain way to try and make sure that your code and your data stay in the cache, and that will give you a massive speed boost. So you can do things like that. Okay, but it's a major way of speeding it all up. Now, anyone know what these two are? Address and data buses. What do you think they might be?
Is it to do with the like internet?
No, it's all internal to the CPU. Nobody knows what a bus is. Yeah, go on. Right, bus is a transport system, yeah. So they carry, in a computer, they're going to carry information, data. So the data bus carries data, funnily enough, from memory, or to memory. The address bus is a special bus that's used to select where we're reading or writing from in memory. Okay, they're used by the CPU, so you're going to have to find out about these a little bit and then explain what they are. Okay, graphics processor. So this is another CPU, and you could argue that a graphics processor is a type of CPU. They're dedicated. Okay, they are one-trick ponies, graphics processors. They are set up specifically to do 3D maths and fill pixels. Okay, they're very, very, very good at it, because when we're working on graphics work, because you're working on a screen, if you set the data up properly, instead of having one CPU draw all the pixels for a screen, you can start splitting the screen up into sections. So if you had 4 CPUs in your graphics processing unit, you could do a quarter of the screen each. But it doesn't matter how much you split. The more you can split it, the faster you can get, because it can all happen at the same time in what we call parallel. Alright, that's why you'll get even a moderate graphics card may have like 384 shader units, which are separate CPUs that can work out and do the calculations for a single pixel on the screen. If you get onto the beastie cards, the ones that cost you a fortune, some of these cards have got thousands of these. In fact, I think the latest ones have got like 4,000 shaders. So they can simultaneously, the graphics cards on the beasts, like 1080 Titans and things, they can fill in and draw to the screen thousands of pixels at the same time. And that's why when you start, when you mess about with that Crisis machine, That's a really crunky old card. An old Radian card, that is. Really old. Can't even remember what. Oh, I think it's. I think it was still AGP when we had that, Advanced Graphics bus. But yeah, so the more, in general with the graphics, the more processing units, they started calling them compute units now. They didn't used to, but they have now. The more graphics units you've got, the more throughput you can get. And even when you was doing the Crisis thing, even that manky scene, if you looked at it, it was not trying to draw about 1.5 million triangles. So each triangle has to be rendered like that, rasterized. So you draw them a line by line. So you work out where the edges are and you draw straight lines. It's more complicated because you've got to work out what colour all the pixels are from the textures and all the effects that are going on. But so even that manky graphics card was drawing 1.5 million triangles. The ones we've got now are scary, really scary. If you look back to films from the 80s when 3D graphics was really kicking off, the stuff we do in real time now makes that look laughable, and that was rendered. That was like taking weeks and weeks and weeks to render each frame. It is quite scary. The power in the GPU, but it is a one-trick pony. You can't run normal programs on them. They're designed specifically to do all the math to do with vectors and 3D. Okay, so there's loads of elements there, and again you've got some of the same things again about clock speeds, data bus width, so how much memory we can move in one go. So in a traditional CPU, we've got 64-bit data buses, so we can move 64 bits of data in one go. Some of these graphics cards have got 384-bit buses, so they can move huge chunks in one read cycle. Okay, so that actually makes a massive difference. So when you look at people doing inspections of graphics cards and they're going in about the bus and they're comparing different ones that got fatter buses and messing about with the clock speeds and things, the data bus width, the raw throughput matters. Okay, and that is another thing that's massively increased. So, anyone know what they are? NURBS. This, I don't know whether they're still that relevant. Right, so most graphics cards are set up like this, so they can work with vertexes, which are points, and pixels. But NURBS is like a higher order shape. So instead of defining everything out of triangles, what you do is you can make like donuts and cubes and bendy shapes. And there was, I mean, this is how old the specification is. This is from 2010. NURBS was something that we're all starting to look at. I think it'll die to death, and everyone went, no, I'll just keep trying to make triangles as fast as possible. Okay, but look at what NURBS is, because you'll need to talk about it. Okay, so we've got RAM. Anyone know what two things are stored in memory? There's only two things that are ever stored in memory. Yeah, that's one of them. Data. No. The thing that does all the work, the instructions. Okay. So the makeup of RAM is to hold the data and the instructions that we want to execute. Stuff that's on the hard drive, the CPU can't execute. So it has to be loaded into memory. We've got a finite amount of memory. Okay. If you run at the minimum, I think Windows 10 2 GB or something like that as a minimum. If you've got no more, then your programs, your applications, your games, they're going to be constantly dumped in and out of memory into what we call virtual memory, and your hard drive like goes crazy because it keeps swapping data. Okay, so the actual capacity, the more memory you've got, the better. There's two things that you can do to speed up a computer if you're on a limited budget. One of them is put as much memory in as you can. That's going to be determined by your motherboard. Some motherboards are restricted. Specific, laptops are really bad for that. But the other thing you can do is increase your hard drive speed by getting an SSD or a hybrid. Hybrids work. Okay. So we've got all these different types. You've got to pick up a couple of different types and explain what their difference is. Okay. This used to be a common one, and then we're moving on to these things, all that DDR stuff. If you want to, I've got no problem of you talking about the difference between GDR5 and GDR4 or GDR3, those things. Alright, so, but as long as you come up with a couple of different ones. And we're still going. We're nearly at the bottom of the first page though. Right, display technology. Built-in displays. So, things that are part of devices. Okay? Monochrome monitors. Anyone ever used a monochrome monitor?
The one on the client screen.
Well, no. What do you think? What does monochrome mean?
Black and white.
It actually means one colour, doesn't it? Mono. They're not black and white. They're not on whatever that colour is, which is it tends to not be black, does it? Unless you're looking at these sort of screens. It's like a dark grey, and then you got white. But they didn't. You didn't used to have just that. We used to have green screen monitors. We used to have amber monitors. Okay, so you had a choice, but it was a choice of one colour. You had to pick the colour. Obviously, that was down to costs. Everything's about costs. What we've got. If you look at how many people have still got an old school CRT computer monitor? Nobody has. Because the LCDs, because they're mass manufacturing them, they're cheap as out, aren't they? You know? Even a really rubbishy PC monitor you can get for like 80 quid. A decent sized LCD ones, like the ones we've got. Okay? Yeah, so things move on. So you just got to explain the difference between monochrome and colour monitors. Most vector games were monochrome until Atari perfected 4-colour, and then you got things like Tempest, you got Gravitas, Star Wars, Empire Strikes Back, all those vector games that you use, but they're more complicated, those monitors, more things to go wrong. In fact, when Atari did the initial Star Wars game, the monitor they had in for that, it was, I don't know whether it wasn't tested properly or something, but it had a very high tendency of catching fire, which isn't generally good in an arcade environment. And they had to have like kits, they gave kits out for them to install to stop them catching on fire. That was quite amusing. Right, and then we got liquid crystal, the same sort of thing you get on a watch, but the thing that the Nintendo Game & Watch use, where you have to pre-decide what all your graphics are going to be and where they're going to be on screen, and then you can turn them on and off. So games like that parachute game where people jump into the water and there's a shark going along. But I think Nintendo made about 30 or 40 of those Game & Watches. Calculators use the same technology. Okay, so it's like they're like pixels, but they're shaped pixels that you can turn on and off. Okay, remember we're talking all about in relation to games. Right, so the last bit, the sound stuff. I don't know whether you did sound card and sound equipment last year at all, did you? I don't think we ever came off, did it? Alright, so this is all going to be new, but you will know what most of these things, the difference between mono sound, stereo sound, 3D sound, surround sound. So those 4 things are slightly different. Okay, so you need to make sure that you explain the difference when he comes onto it. What do we mean by channels of sound?
If you've got a surround system, you've got like 5 or 7.1.
Yeah, so it's unique streams of audio information. I mean, we're used to stereo, which is 2 channels, so you get left and right ear. Okay, but if you look at the big cinema systems, they can have like 50 or 60 channels of sound. It's insane. But you do get a really good spatial effect with more channels. And you can have like subwoofers, and you can have tweeters for the human speech and things like that, so you can pick up sounds better. But you have dedicated channels for different things. Anyone know what that means, sampling rate? Or what sampling is? No, nothing. Right, when we're converting sounds, natural sounds, into a computer, we have to digitize them. So we have to take them from a varying domain where you can have an infinite range of things to a discrete domain for the computer, so we can actually work with data. How often we look at what the sound levels are determines how accurately we can reproduce sound in a computer. In a CD quality music system, which is what we've used for a long time, we look at the audio we're trying to sample 44,100 times a second per channel. Okay, audio can be really big, and it can be a big chunk of games if they're using 7.1 surround sound, because you've got, well, 8 channels. All right. We call it 0.1 because the bass is a collection of all the sounds put together. But you can go up to those sort of speeds. So take 192,000 samples a second. The more samples you take, the more accurately you can represent the sound waves. So if you was to sample there, 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 and there on that sound wave, all you would represent in the computer is that shape. So you've been missing out very important frequencies. So it wouldn't sound the same at all. Okay? If I take more, I can't get it exactly, but the more I take, the more accurately I can represent the curves of the waveforms of the sound. But the more I take, the more memory it takes up. Okay? And the faster the audio processing system has to be able to handle that data. Alright, so there's a trade-off, quality over space taken up, which there is with a lot of things in computing. Okay, so make sure you get a really good handle on what the sampling rate is. And obviously if you're sampling, every channel that you're sampling extra data. Okay. Right, we'll move on to the last page. Right, storage media. The media where we store games on has changed throughout. We still use some of them have died. Some of these you could probably spot which ones have died. So, ROM cartridges, we still use ROMs. The old original arcade games use ROMs. Little chips, stuck them on a board. You might have had, because they were very small, they might have only been, what, 1K, 2K in size. The later games, they start getting bigger and bigger and bigger. But they were individual chips, so that's not practical for home users. So we end up with cartridges, little edge connectors, but they've still got ROM chips in them. This is what we use in like Nintendos, Mega Drives, all those sort of things. You've also got flash memory ones that allow you to change the data that's on them. Okay, these are actually really handy for when you're developing games for systems, because you need to be able to upload your new code and things. But you also get the R4 cards and things like that people use for piracy. So someone can make a cartridge that pretends to be a cartridge of the system, but actually it's a flash cartridge, and you can just keep putting different games on them. We've always had these sort of things. Okay, back in the Super Nintendo days, you used to have these, we used to use floppy disks. You had Super Magicoms, they were called. It'd plug in, it had some memory that could hold the game, so it pretended it was a cartridge, and you put your floppy disk in with your game on, it would copy the contents of the floppy disk into the pretend cartridge, and then you turn the machine on it and go, oh right, okay, you've just put Super Mario World in. No, I haven't, it's a floppy disk. So people have been always doing this, and that was before the World Wide Web. So people used to have to dial up computers that stored all the stuff. You had to know where the computers were. You used to have to know the telephone numbers of the computers. So piracy was possible, always been possible, a lot harder than what it is now. Now it's just a search on the internet. Okay, optical discs, these come and go. So we started off with the old laser discs, then we had CDs, now we've got Blu-rays, although there was the HD DVD that died a death. Blu-ray, I don't know, is it going to die out? I think eventually people are going to stop wanting physical optical media. I'm quite happy. I watched, because I never got around to watching the pictures, I watched Guardians of the Galaxy 2 at the weekend. It's a lot easier to pay £4.50 to stream it than it is to pay 9-10 quid to get a DVD or whatever. And you're never going to watch. You might tell yourself, I'm going to watch that 15 times, but you don't. So you're wasting your money. So with games, the problem with games is they're bloody massive. Okay, some of these games are coming in at 50 gig and above, aren't they now? But on consoles, it's a real pain. So even if you deliver it on optical disc like Blu-ray, Blu-ray can only hold 50 gig. So you end up with 2 discs, and nobody likes swapping discs. That's stupid. So at some point, we'll probably go completely discless. Okay, Sony already don't let you on the PS4 play audio CDs because they want you to use Spotify, their service. I think is the real reason, because it's not hard. It's not hard to implement that because they had it on the PS3. But you know, I don't get audio CDs anymore. I used to get audio CDs all the time, but I can't be bothered. Just like I used to get tapes, the tape players. I don't bother with them. Right, this one's a funny one. Sony again. UMD. Again, Sony with that love their proprietary formats that they control. It was never going to work, UMD. Too small, too slow, too damageable. It's what killed the PSP, let's face it. If they'd have just gone for some flash cartridge format, or even just like a SanDisk memory stick, you know, SD stick, then they'd have been alright. But they decided to do UMDs. I've got a stack at home because I had a PSP and I bought loads of games. PSP screen broke, couldn't be bothered, do anything about it. I've just got a stack of discs now. Totally useless to me. Magnetic tape. This is an old school thing. We still use magnetic tape for backup. Okay, because can have quite a high capacity. But we used to have like tapes, and if you wanted to copy a game, you just got a tape-to-tape machine and you copied one tape to another. What you tended to do is you bought a really big tape, like a 90-minute tape, because games are about 15 minutes. That's how long it took to load. You wanted to play a game. I know you lot probably moan, oh God, it's taking ages to load up. But when you had to wait 15 minutes for it to load, and then it went, the tape clicked because it hadn't loaded properly, and it started all over again. That was annoying. But we still use magnetic tape for backups, but we did use it. So have a look at that. So look back to the old school machines like Commodore 64s, ZX Spectrums, things like that. So anti-piracy devices, that's actually quite an interesting one because that's been developing year on year on year, always trying to keep ahead of the pirates. There's one big problem with games: you can always hack the code out. You can make it really take a long time to get the code out that hooks up to the anti-pirate device, but it can obviously be done. It's just software. Okay. I know when I bought Outrun 2006 for PC, and that had anti-piracy thing on it, and it was really annoying. And I wanted to be able to just use it. I had a cabinet set up and everything, so I just got a bit of software that ripped all the security out because it was annoying. The security was really annoying. We used to have on old school tape machines, we had a piece of plastic that you bent like this and had to sit on your screen, and it had like it was like this shape. It was just a piece of clear plastic that distorted the image on screen, and they put a code up, and if you didn't have this piece of plastic over the code, you couldn't read the code, and you had to type every time you started the game, type it in. But the problem was, it didn't take account of people having different TVs and different size TVs, so it didn't work very well. So you buy a game and you actually couldn't ever play the game. They used to do other things. They'd have like coloured sections inside the manual, and they'd ask you what is on page 16, paragraph 3, and things like that. I remember writing out my mate's manual for his game, the entire manual, which was like a story, just so I could play the game. So there's always ways around these things. It's just how much time can you be bothered to do. But anti-pirate device is quite interesting. For the merit and distinction, you're going to pick one of these things from each category to just explain a little bit more detail. So if I was doing this, I might look at that because that's quite interesting, the old antivirus stuff. Right, the devices, interface devices. There's quite a list on here. You can do it discreetly, or you can lump a few of these together. Okay, so we've got like wireless and cable devices. We've got analog and digital. Digital is on and off, so you're either pressing a switch or you're not. Analog, like a thumbstick or a trigger. you're varying it. Like a steering wheel, you're turning it. There's more precise control. Good for something where you aren't just jumping or going left and right. Okay, so perfect for that. Talk a little bit about the actual sockets that these do. I mean, generally it's USBs these days, but not always. Some of the console manufacturers have got the custom little sockets for connecting things, but on modern machines they're all wireless anyway. The only time you ever socket it up is to plug the USB in to pair it or something. Okay, so there's a few that you've got to talk about. You know what these things are, all in the context of gaming. Nearly there. Right, and then networking. Networking's all over the place. I remember when my PlayStation 3 first yellow lighted of death on me. I had a fat 60 gig one, and it was like, right, okay, take it to bits, get a hot air gun. So I went and bought a hot air gun, cook the motherboard, because that's what's happened, it's dried out. Does anyone know why all these electronics dries out and you get all these cracked joints? No? It's the type of solder we use. We're not allowed to use lead in solder. Everything we use is lead-free solder. Now the problem is, it dries out and cracks when it gets hot. You're not going to get much hotter than a console that's in a compact little box that can't get rid of all its heat. Okay, so all the problems that we've had with modern consoles dying on us with these funny errors is to do generally with solder. Okay, drying out. So you get like a connection, so you've got a nice solid connection to start with, and then what it does, it dries out, it gets hot and then contracts and you get a crack. And it only takes one of these and that screws the whole machine. Which is why the hot air gun thing, anyone done that to their 360? Hot air gunned it. It works, and then it'll die again.
I think do that with graphics cards as well.
Yeah, same problem. Same problem, they're getting hot and cooling, and it cracks. You get what we call dry joints. Yeah, it's a real pain. It's a real pain. But it's to do with the solder we use, because we don't want to pollute the environment.
Can you buy better, like cooling systems?
Yeah, I mean, you can't for a console, can you? But you can for graphics cards. If you're getting that happen to graphics cards, you need to look at the cooling, really. Okay, so when I took my PlayStation 3 to bits, and then I put it all back together, it was working, couldn't get any controllers to work, couldn't get the Wi-Fi to work, couldn't get the networking to work, and I'd left one cable off that was doing all the work for this. I think it was powering the whole networking board. But all these things, LAN and WAN, local area network, like what you did with the Xboxes, okay, where you just like locally connect them together. Wide area network, that's what the internet is, the biggest example we've got of a wide area network. Right, anyone know what the difference between the internet and the World Wide Web is? Everyone seems to call the web the internet these days. You don't.
I know there's a difference.
You know there's a difference. Right, the internet is the network of computers.
Yeah.
That's been there since 60s, 70s. Okay? We used to go, well, at my university, we didn't have internet access until my final year because we had someone hack the American defense computer from my university, and the university got pulled off the network for students because of him. And so we never had it until my last year, but this was before, this is in the 90s, early 90s, before the World Wide Web. And to communicate across the network, you used to have to dial up, you have to know what computer you want to connect to. You need to know the addresses yourself. Okay? What the web does is put a layer on top, the browser, it does the looking up for you. Okay, so it is still on the internet, it's just a nice interface to it. That means normal human users don't have to remember things, they just blindly click on things. So all this like, you wouldn't be able to do YouTube where you just like, oh, click on the next video for the next 4 hours, keep watching videos, because you'd have to like be able to know where they all are. Alright, so the internet is not the same as the World Wide Web. So when you talk about the internet bit, make sure you're talking about the network behind it all, and not talking about web browser stuff. And then Wi-Fi and Bluetooth, they're the same technologies, they're just different frequency ranges. Wi-Fi's got better range because it's higher power. Bluetooth we tend to use for controllers, remotes. The distance you can really get Bluetooth to work is about 10 meters maximum. Okay. And then the last two, internal batteries and external power sources. Remember, in relation to gaming. So you're talking about adapters and things, not, you know, low current, not high voltage stuff. Okay. Right. Anyone got any questions about that? So for the pass criteria, you need to describe all those in relation to games. Not mega detail. I don't want mega detail. That's not what I want you to just say. Yeah, I do know what all these things are. That's what the pass is all about. When you come to the merit work, you're going to pick. So you don't worry about that now. But as you go through this, just make a mental note. Oh, there's probably some stuff I could talk about here on that specific one, and I might use that one for the merit. So one from each section for the merit. Okay, to just just say what they are in relation to games. All right. Yeah. So the merit, pick one from each category and explain its meaning to gaming, and then for the distinction, that same one you picked. So I can't remember how many sections there are, but 8 and 9. You're going to talk about the pros and cons. So strengths and weaknesses, advantages, however you want to describe it, of the thing you've picked. So bear that in mind when you make a decision on which one you're going to do in more detail. Okay, right, I'll load that up so it's there for you to look back on.